as well. So it's very useful from that front in terms of dating. The only problem is it is a destructive process right now. You need to actually saw off the margin of the obsidian artifact. You'll leave a small gash, and then you actually need to grind that down and actually put it under an electron microscope. So it is fairly destructive. It does remove a small little sample. It'll have like a little, uh, pretty much about 5 millimeters wide is some of the smaller ones you can see. And generally they'll intrude in about a centimeter or so into the artifact. So it is destructive, but it's also useful because you can actually get approximate dates for things like obsidian debitage or bifaces, things that are not temporally diagnostic. So you'll hear me talking about primary deposition and then secondary and tertiary deposition throughout the presentation. Primary deposition, it's the original place that lava laid it down. It's commonly going to be the largest source for that obsidian. You can see dedicated quarries on site. So you can even have workshops immediately on or immediately adjacent to the quarry as well. Secondary, tertiary sources. Actually, let me go back. I guess not. Just for the picture on the left, that is again another one of Glass Mountain. You can see how tall the trees are. Those are about 100 feet tall. And then it's just this huge, just an expansive mass of obsidian. It's amazing if you get a chance to go out there. And on the right is Cougar Butte source. And this one is really odd from what I can tell. You can actually see thin bands on the right. Well, the black stuff in between those bands is obsidian, and then you have layers of ash between them. So it's almost like there's dozens of alternating layers of obsidian and ash, and it's something I haven't really seen a lot of in California. So it seems fairly unique. Secondary, tertiary deposition. So erosional actions can actually move obsidian from where it was originally deposited. It can be done by gravity, but most commonly by alluvial deposition. So this alluvial activity, as it's moving down the water channels, it's bumping into things, it's grinding against things, it's getting hit a lot, but it's not getting hit hard enough to actually remove flakes. So when that happens, you get incipient Hertzian cones on the surface. And as it weathers down, as it's transported down and it's eroded and it goes through like a rock tumbling process, those Hertzian cones weather down and you start to see little cones and little moon-shaped scars on the surface of the material. And you see that on obsidian, but you can also see it on any nappable material that goes through alluvial deposition. So the middle photo right here, this is from the Warners. This is the lodgepole source. You can see the hillside. It's entirely black. Well, that's active erosion by gravity. The stuff at the top, it's eroding downhill. It's going to wind up at the toe slope about 5,000 feet down the hill. On the right is near the grasshopper, near the Lost Iron Well source. You can see there's really small little pebbles of obsidian intermixed in with pumice. And that's an example of, again, floodwaters came through, the lighter material, the smaller material that gets transported farther due to the alluvial action. Chemical fingerprints are also very useful. Every obsidian source has its own unique chemical fingerprint. This is basically looking at trace elements within each obsidian source. So what is shown is I think it's a trinary graph or trinary graph. But basically you can take the percentage of these three elements, strontium, zirconium, and rubidium, and you can actually see that the clusters of the material source for the North Coast range, they are very distinct from one another. So that's how you actually tell what source it's from. In order to do this, you need to actually subject the sample to X-ray fluorescence. Used to be you'd have to send that out to a big firm, Northwest Obsidian Laboratory, Orager, up in Santa Rosa. But now you're starting to see handheld XRF devices for around 50K. Those are very handy because you can actually just scan them in the field and you can have sort of instant results back, which is nice. So like I said, certain trace elements help indicate where the obsidian came from. Strontium, zirconium, rubidium, those are the main three. But you can see there's very close, and a lot of sources you're going to have significant overlap. So you really need to go into some of those other ones to actually look at what sets it apart from the others. So manganese, niobium, and yttrium also help differentiate from different sources. Currently, there's no correlation between elements and different visual varieties, but I don't think anyone's really looked that hard. Offhand, I'd say if it's exceptionally gray, that obsidian, it likely has a higher level of titanium in the trace elements. I think that's something interesting. I think it's something that we'll be open to in the future. But for right now, typically when people do XRF, they're really only looking at 7 to 10 trace elements. These handheld devices, they can have really up to 50, 70 selections as well for additional elements and chemical compounds. The only problem is it's not consistent. If it's not seeing a certain element or a certain um element, then it just skips it. So you don't get a consistent output, which can really hamper some of the analysis. So finding sources through the numbers, you'll shoot something and you'll get a parts per million for the various elements. And then you'll have plus or minus a margin of error, usually 1 to 5, depending on the type of element. So after you get that, then you need to start sitting down and you need to start going through the various sources and just see what is the best fit. You can see Cougar Butte and Napa Valley, they're very similar for a lot of these, but then the new niobium and yttrium really set them apart. So you might start off with a strontium value of 2. You see, oh, okay, well, I narrowed it down to 2. It's definitely none of these. The rubidium could be 150. Well, that falls within both of these. That doesn't really help. The zirconium, it's about 170. So you're like, oh, okay, now I'm thinking it's Napa. The manganese is about 100. You're like, okay, that falls within Napa Valley pretty well too. And that's generally how you get the sourcing down. You can also run through statistical analysis, the z-test as well, and actually get an R correlation for what value it belongs into. But that's a lot of math and statistics, and I don't want to really get into that right now. Another interesting thing I want to go over in terms of the quarries are really talking about them as middle archaic production factories. Before bow and arrows, there's widespread utilization of these quarries to produce bifaces for trades. These would go hundreds of miles across the state. They trade them for food, goods, shells, a lot of other things. And then whoever receives them, they would actually just finish the artifact off into whatever they want, knife, dart point, and you just repeat the process for thousands of years. Now, when I say producing bifaces for trades, I don't mean a few hundred, we're talking thousands each year. And that's very, very big. Cobbles at the quarry would be roughed out. You're removing most of the cortex. You're doing some shaping. You're verifying quality. You want to make sure that there's no fault lines in there. Interesting thing about this biface manufacturing technique is at the Napa Valley source, they actually went out of their way to keep a little bit of cortex at each end of the biface. And usually it's less than, I'd say, 5 square millimeters. It is the tiniest amount of cortex you've seen, and it would take just a pressure flake to remove it, but they went out of their way to actually keep that on there for some reason. Far Western believes this is some sort of way to do, I think it's cost signaling, sort of like a marker, maker's mark. I think it might be a little bit more practical. Cortex may be a little bit extra of a buffer for trade and travel, but that's just something to look out for, and not really seen on some of the other quarries. So the roughed out bifaces would then be taken to nearby workshop areas for further reduction, then transport out for whatever trade's going on. The biface size, that depends on the individual source and the size of the nodules and cobbles. Some of these sources, like the Glass Mountain, they have full-on boulders, well over a meter, and that's where the wealth blades in the northwest are coming from. Um, there's some of that down in Casa Diablo as well, I believe. I've seen some giant wealth blades down there. So naturally, the bigger the material, the bigger the biface. Most of the time, you're struggling to get stuff bigger than a foot. Ballpark, you can characterize most of these trade bifaces as around 8 to 12 inches long, 1 to 2 inches wide, maybe half an inch to 1 inch thick, maybe a little bit bigger. Leaf shaped, usually biconvex cross section, and those would just get busted out of the quarry and just packed off and traded. Debitage density at these workshops can average over 20,000 artifacts per cubic meter. At Mono 3, which I excavated a while ago, a little 10 centimeter by 10 centimeter by 10 centimeter block of dirt contained over 3,000 flakes per level. And that's, doing quarter inch. So it just gives you an idea of just how much debitage can accumulate in some of these areas. At Napa 399, several discrete obsidian features were actually found, some of them that exceeded 400,000 flakes per cubic meter. In those cases, there was almost no dirt. It was just flakes laid upon flakes. Those are either discrete workshop areas or discrete disposal events. The very largest one was found on the periphery of the site, about 3 meters deep, and it was just massive, like 3 flakes above it, and then all of a sudden it's just straight obsidian at the bottom. Once bow and arrow technology adapted and got implemented, these biface production centers and the trade of obsidian bifaces essentially collapsed across the state. And there's a couple reasons for that. It was almost like the tribes that traded for these larger bifaces realized they could use smaller raw material. As you saw earlier, some of those obsidian sources, they only have really small pebbles left. Well, that's not really useful for dart points, but you can use bipolar technology and actually make arrowheads out of them. Or you can utilize core technology out of some of those and again, make arrowheads a lot easier. Or they can utilize older, larger waste flakes, which, are abundant. They're everywhere. Recycling. There's been several caches of bifaces discovered around Northern California, some of them from various sources. I know of one from Napa, Borax Lake, and I think it was Canocti. But essentially, they were cached. People think they were just stored there, come back later and get them. But all these are sort of from that same time period when arrow technology was adapted and implemented. So I think a more likely possibility is, the demand for them was essentially gone, and they could either schlepp them back 100 couple miles back and get nothing for them, or they can just bury them there and save themselves an easier trip. So some of the typical research questions you'll see associated with quarries: when was the source utilized the most? Can any changes in use be attributed to changes in climate or shifts in native people? What's the geographic extent of the obsidian's distribution? You think that'd be an easy one to do, but a lot of times the projects, the surveys, they're project specific, and that project has a set boundary, and oftentimes you're not going to encompass an entire obsidian source in that. Another thing to consider is where these obsidian sources are, and I'll show you where those are later. Not a lot of big infrastructure projects near them, so really there's not a lot of overviews of big surveys that are going out saying, hey, let's get the full extent of these. They also want to know, how does that change over time? Were certain visual varieties preferred, and does that change over time? What can debitage tell us about manufacturing technology and how it changed over time within and adjacent to the quarries? What is the debitage density across the deposit, and how does that compare to other sources? Were certain areas of the deposit exploited at different times? Does the visual characteristics or cortex type vary across the deposit? What's the spatial extent of the primary, secondary, tertiary deposits? A lot of these are sort of unknown for a lot of the sources. Trade, like I was talking about, it goes a lot further than you thought. A very large obsidian biface over a foot long has been found in Orange County that came from the Warner Mountains, several hundred miles to the north. Medicine Lake Highlands obsidian, you're going to get that all the way in the coast near Eureka, but also that's going to go down into the coast range until about Ukiah, Cavello area. You have Borax Lake material going all the way north up into the coast range. You have Napa up and down the coast. You have Casa Diablo coming down from the Sierra foothills, crossing the Central Valley, going to Monterey. You have Coso Diablo uh, at the very bottom, and that pretty much goes throughout the desert. As you can see on this map, there's a lot of other obsidian sources nearby as well. Some of those make it in, but it's really dominated by several of these obsidian sources in terms of trade. Here's an example of a giant wealth blade from Siskiyou County, over 30 inches long, made of obsidian, just telling you how big the raw material for that needed to be. If you look slightly to the right of center of the photo, you'll see a sort of a greenish blob on the biface. That's where they actually used mastic in the old days, when probably it was made or used by the prehistoric people to actually glue it back together. Then they added some notches so they could actually tie it and try to keep it supported and in one piece. So now let's actually see some of these different types of obsidian throughout California, because it's not just black. There's a lot of different types throughout it. The one on the left is called triflow. You get black, you get red mahogany, you get clear. You have these distinct bands. This is typically found up in the Warner Mountains. It's one of my absolute favorites. It's just so incredible because every single rock is slightly different. There's no really set pattern to it. So the swirls, the mahogany, it can really vary from specimen to specimen. And that's what I love about it. And while not in California, the Armenian dragon skin shows you that, you can have colors like almost blue. And it's just a really beautiful source as well from Armenia. But there's also some sources of the teal obsidian in North America, the double H source in Nevada, and I think there might be a couple in Mexico as well. But just a spectacular looking source. Then we have rainbow sheen obsidian. It looks like an oil slick on the surface of it. It can be quite beautiful. The color ranges from, full on rainbow, but it can also go distinctly into certain colors. You can also get a gold sheen and silver sheen where it just looks like spray paint on the rock, but it's the actual glass itself. And that's coming from microscopic bubbles on the surface that have been stretched as the obsidian cooled, and it's reflecting light at just the right angle to give you that color. Here's a green example of rainbow obsidian, and here's some Lassen blue, so you can really see those distinct colors pop. Again, all of these are from the Warner Mountains. It's a really incredible place if you ever get a chance to go up there. Now, don't go out there expecting to find colors like this. Um, it's quite rare in terms of getting spectacular color like this. It's really rare to find really good color like this. You'll find a small little pieces, couple small pieces with some slight stuff, but a lot of this I'm thinking is coming from rock shops that are doing really big processing of materials. Now, we talked about some of the visual characteristics. And like I said, a lot of the times in the field, folks just like to say it's black obsidian, and that's fine. But we can actually talk about different visual characteristics, and that can actually help inform us. One, are there multiple sources, which can help inform research questions pertaining to criterion D of the NRHP analysis. And also, some sources have distinct visual characteristics that will actually help you identify where that source is without the use of XRF. Borax Lake is one of the easiest things to identify because that obsidian has a lot of bubbles in it. It's very frothy looking, so it's very distinctive to call out and identify. So, like I said, there's more to obsidian than just black glass. You can describe several characteristics to help narrow it down. Characteristics are based on how the lava cooled and likely the chemical makeup of the lava. And some sources have a very limited range of visual characteristics, while others can have a very wide range, as you saw in the Warners. That's some of the more colorful varieties, but they also have the typical black stuff. They also have gray. They have stuff that looks like dacite. It's very variable up there. And taking time to describe these can help narrow down potential sources without the use of XRF. So one of the first characteristics you look at is hand color. What is the color of the specimen when you're holding it in your hand? In this case, black, but you can see there's a whole mess of other colors that you can actually use. Reds, greens, teals, grays, almost clear, even some almost oranges and yellows. So really being able to just say what the hand color is, even if you have to say like it can be both, it can be multiple colors, being descriptive in that frame helps narrow it down. Now there's also color texture. You can have distinct banding on the obsidian. It can be a little bit cloudy. You can have samples that actually have veins. It looks like fractures running through it. That's not that common in California. It's more elsewhere. Uniform, where it's all the same. You can have mottled, where you can tell they're sort of different colors, but it's just sort of rubbed together and you can't really tell discrete areas. So the example I'm showing you is black and gray, but it sort of looks more like gray and brown in this light. You have indistinct banding as well, where you can only really tell that there's banding in certain situations, like you really need to take your time and look at it, and then you can see really subtle variations in it. Then you have mahogany, and then you have swirls. So color hue, that's when you hold it up to the light to actually try to get the color. You can see here that very same sample. It went from black to now it's black, but it also has light gray. And now we can actually see that there's some distinct banding in it as well. So light transmittance, you also want to describe that. It's how much light goes through the material. So it's sort of a continuum, and it also depends on how thick the material is. The thinner the sample, the more likely it is to be translucent. But opaque, and you can see even on the very edge of this, the very corner, the right corner of that, it actually has a little bit of clear because that's actually triflow. Semi-translucent, light's only passing through the very edge of the object. Translucent, light passes through it, but letters and numbers are obscured. You can't actually see totally through it. And transparent, light passes through it easily and letters or numbers can be seen and read. So as you can see on this example on the right, you can actually see through it. And while you think that transparent means clear, that's not necessarily the case. Now, talking about surface luster sheen, you saw the rainbow sheen, you saw the gold sheen, you saw the electric blue, the Alaskan green. Well, those are all examples of chatoyant luster sheen. I'm not sure I'm pronouncing that correctly or at all. That is a pearl-like sheen or iridescence. And again, that's from a very thin layer of microscopic bubbles that have been stretched out and are catching the light just right. Adamantine, it basically looks like a diamond, not really applicable to obsidian, but keep in mind that these descriptions and visual characteristics, they can carry over to different material types as well, like cherts, basalts, fine grained volcanics, etc. Greasy won't come up too often. Resinous, it resembles resin or amber, almost glassy. You will see that on some of the lower quality glass where there's a lot of imperfections, where it's almost like obsidian, but it's also sort of almost like rhyolite. You have earthy where there's really no luster. It's matte, it's grainy, it's not really shiny at all. Some of that might be considered almost like dacite. Vitreous, it's glassy, it looks nice. That's what people typically think of as obsidian. Surface texture is a little bit harder to describe without actually having samples or a really good camera, so I apologize for this. So on a freshly exposed obsidian surface, if there's absolutely no imperfections, it's totally smooth. If you see things that are like ash pockets, phenocrysts, in this example, it's called Hackley because it's very poor quality glass. The surface texture can be grainy, and you've seen that on some of the really sugary obsidians, not really in California, but there is some up in Oregon. When you see basalt debitage, that's what you tend to think of in surface texture. It's really grainy. Flawed, it's a little bit harder to describe, but if you can see on this photo, you see tiny little white streaks in small little pits. That's telling me that there's actually really small microphenocrysts in the glass, and it's otherwise smooth glass. That's telling me it's a flawed surface texture. And then matte is the surface is dull, but you can't actually see any phenocrysts, and you can't actually see the grain color or grain size at all. In terms of inclusions, you can get accidental, which I haven't actually seen personally, but just know that when there is a new lava flow, that's going on top of other rocks. So there is the possibility that those rocks get picked up, encased in the obsidian, and then they're sort of accidental inclusions. Spherulites, a lot of people equate this with snowflake obsidian, but spherulites are different than phenocrysts. Phenocrysts are small little ash pockets. Spherulites, they're circular in nature, and they usually have concentric rings of ash inside them. They're sort of like a jawbreaker, essentially. Like there's just layer upon layer upon layer of like fine crystals. It's really not good tool quality stone because once you hit that ash pocket, the flake dies, and you're going to have a big circular depression when that spherulite actually pops out. So it's not that good. Bubbles are pretty much air trapped in it. Some sources have lots of bubbles in it, like Borax Lake. Others have very, very, very few bubbles, maybe just one or two on the surface. And there could be some that are actually have more bubbles towards the outer edge of the cortex of the material as well to further complicate things. And then there's actually some that don't have any inclusions. It's the really nice stuff. Megascopic phenocrysts, those are the ones you can see with your naked eye. But sometimes you need like a really small microscope or handheld lens to see some of the microphenocrysts. And I tried to zoom in on this, and you can see some of the white dots, some of the streaks. Those would be microphenocrysts. It's almost like when you hit the ripple in the obsidian, it sort of finds a rock and it flows around it, if that makes any sense. Now, talking about cortex, and again, this can be applicable to other sources as well, in other materials, you have crenulated, which again is typically found in alluvial depositions. It's formed from Hertzian cones being impacted into the material, then ground down, riverine transport. I have seen some up in some of the primary contexts as well, so there may be some similar glacial action with that as well, creating that crenulated cortex on small parts of it. But the riverine ones will just be 100% crenulated. Chalky, not applicable to obsidian, but there are some chert deposits where you will have an outer cortex of chalky material. You can also have some obsidian that's totally cratered. Um, very haven't seen that too often. I know the Napa source has that. Oddly enough, on the project I'm working on right now, I found a 1-inch primary flake with a cratered from Napa about 300 miles to the north of the source. And I just cannot think of a good reason why a primary flake would travel that far unless someone was saying like, hey, you guys ever seen a weird cortex like this? Then, of course, you can have smooth cortex. You can have rough. It can vary anywhere in texture from, 80 grit sandpaper down to 400. It can grade into smooth as well. And then again, not really applicable to obsidian, but included for the sake of completeness, bumpy lobed, usually found with chalcedonies. There's a scientific term that starts with an L that I cannot remember off the top of my head for what that actual name is. So, like I was saying, in terms of visual characteristics, some sources may be simpler than others. This is just a quick little visual source tally I made up as I was traveling across some of the obsidian sources earlier this year. This one's from Little Glass Mountain, and you can see it's pretty much everything I looked at in that area was the same material. So that's telling me it's pretty limited. Here's the Grasshopper Flat, at least one of the localities I looked at, and you can see that there's quite a bit of variety there. And you can see from the tally that some types are more common than others, and then there's some that are just, really, really rare. So actually going into where these obsidian sources come from, these are roughly described and broken up into the geographic context for them. So the Clear Lake Volcanics, it's pretty much comprised of Mount Konocti and the Borax Lake flow. The Mount Konocti flow is absolutely huge. It covers several square miles, and it is some of the worst obsidian I've ever seen. It is full of phenocrysts. It is very hard to work. Apparently, there is some nice Mount Konocti, but I have never seen where that's coming from. And then the Borax Lake flow is very small and was totally bulldozed over in the 50s. So there's houses on top of it now. So it's just a weird area. So that's where a lot of it's coming from. Borax Lake source was not that big to begin with, but you will find it hundreds of miles from this area. The Sonoma Volcanics, there's a couple discrete areas around the Napa Glass Mountain source, a couple localities. You have Anadel, next ridge over. You have the Los Guiacos and the Trinity source as well. You have Franz Valley as well up near Calistoga. These are just approximate locations. And the Napa Blossom Creek locality, I think should be Franz Valley subsource, but I have to do a little bit more research on that. The Medicine Lake Highlands is really, really remote, but there's also a large number of sources out there. There's probably dozens of distinct chemical sources. You can see just a couple of these in the area. The Grasshopper Flat, Lost Iron Well, those are a major source for a long time. Glass Mountain, it's very distinct. If you go into Google Earth, you can actually see a lot of these distinct lava flows, but not all the lava flows are obsidian. Glass Mountain, a lot of it is not obsidian. The really good stuff is down here in the center. Everything out here, from what I saw, was pretty much just rhyolite. And a couple of these are barely even worth talking about in terms of obsidian. Like, I really don't think some of these are really going that far out. Like I was talking about, the Northern Warner Mountains, you get a lot of stuff up here. There's a whole bunch of sources. There's several distinct chemical sources. Ignore the uh, yellow line, that's just roads. So you can see there's a couple up here. What's nice about this area is you can actually go up and collect, and we'll talk about that a little bit more later. To the south, there's several other sources. I haven't actually had a chance to check these out myself, but you're starting to get into the Lassen National Park area right now. These don't get over to the coast that often. Then we have the Tuscan source. As you can see, we have Redding down here, and then you would have Bernie up to the upper right. That's a very widespread deposit, and there's actually even more further to the south in terms of discrete locations. The neat thing about Tuscan is it's so widespread because it is not in its primary context. This is secondary deposition. What happened was the primary source got totally obliterated during a giant lahar or a mud flow that originated from to the northeast, and all that soil and mud just came down into the Central Valley in this area. So you'll see discrete little areas of obsidian throughout the area, and that's the Tuscan source. The east side, at least the northern portion of it, very fun area if you're ever in the area. The Bodie source, that's traded wide and far. I think it's made it into the Central Valley. I think a little bit gets to the coast. Casa Diablo, the Obsidian Dome, Lookout Mountain, Sawmill Ridge, Prospect Ridge. That's the Casa Diablo sources. Those are traded wide and far. There's just a ton of obsidian there, literally tons. And if you ever find flakes that are about a foot long in the area by one of the ranger stations, it's because a couple archaeologists got drunk and tried to make a coffee table sized biface a number of years ago. Did not go well, but they had fun. Anyway, you can see there's just a lot more sources near here, particularly up in the Nevada area. Further to the south, you see the Fish Springs. You have the saline sources. You have the Coso stuff down at the south as well. You do get some down in Southern California as well. Obsidian Butte on the Salton Seas, very distinct, very small, not traded all that far. But you can see there's a couple others in these remote places. So I said there's a possibility of collecting obsidian. You can. So you can collect up to 20 gallons of obsidian free on the Modoc with a collection permit per person, and that's roughly 300 pounds. The permit's only available in the Alturas office between July and October. Cannot use it the day of issuance, which is a little bit of a pain. And there's 4 collection areas to choose from on the right. What's nice about this is those are pretty nice roads, and you can go out there and pretty much just a typical, commuter car. There's also a road cut off Silverado Trail north of St. Helena and Napa Valley. If you want to get some fist-sized Napa Valley stuff, you can pull off the road and just stay safe. It's a big ash cut off Silverado Trail. Malkanocti, like I said, is all over the place. Most everything else is on agency land, so shouldn't go out and do a lot of collecting. And then you can buy from various online sources as well. There's rock shops and stuff, but a lot of their stuff's coming from out of country. So here's what some of the collection areas actually look like. On the left is Pink Lady, and on the right is Middle Fork up in the Warners. You can pretty much just go up there and collect to your heart's content. You can excavate as well. There might be some actual mining claims on the Middle Fork. I know there used to be. I'm not sure how that is anymore. Here's an example of what some of the obsidian sources look like a little bit closer up. This is the Lodgepole locality, Buck Mountain Group. As you can see on the photo on the right, it's almost like there's no soil whatsoever. You have different types of material popping up. So you have mahogany next to other stuff as well. It's at 7,500 feet, and I swear it's probably about a square mile or more. It's absolutely massive. And what's interesting to note is you see a lot of obsidian, but you're not seeing a lot of flakes because that's such a big area. They're not working everything, which is, again, going back to some of those research questions. Here's the Cougar Butte. As you can see, the very distinct banding in the obsidian. There's a giant pit out there that's probably about 20, 30 feet deep. So they were doing some mining there at some point. And there's a good example of what the spherolites look like. I'm pretty sure that's what they were going after. And again, I don't really know why they're going for that material. And as I said, Glass Mountain, it's a really, really cool place to look at. There's a lot of other volcanic objects out there. You can't collect anything, they will find you, but you can see the large blocks. You can see some of the workshop areas as well as the base of the materials at the flow. And this obsidian is less than 1,000 foot or 1,000 years old. So in conclusion, wrapping up, obsidian's cool. It's useful for dating. It's more prevalent than you realize. Some of that is out there for you to collect. And thank you for your time. And here's some of the references. You can look at some of these authors for additional information as well for some of the specific sources or broad overviews. But that is essentially it. So I will stop sharing my screen now. Thank you so much.
Yay!
Oh, I did not see there was chats.
Yeah, there's a couple questions in the chat.
All right, sorry, from. So in terms of the counties on the slideshow, sorry about that. The Clear Lake stuff, that's Lake County. The Sonoma Volcanics, that's Napa, Sonoma counties. The Medicine Lake Highlands is going to be Siskiyou and Modoc. The Warners, that's all up in the Modocs. The Tuscan stuff, it's pretty much every Central Valley, pretty much the entire Central Valley. I can't remember all those off the top of my head. The east side stuff, that's Mono and Inyo counties. Same thing for the south side. And then the last one was pretty much all Southern California, so all those. In terms of the TriFlow, yes, that's the actual photo as it was cut in the slab. And it is actually green in the light. The trick with the sheen is you need to just position it right in your hand. So you need to actually twist it and hold it right just to get it to pop up in the right hand. So when you look at it full on, it may just look black, but you may need to hold it obliquely to the surface to get the colors to pop. And then, of course, having a wet surface makes the colors pop even more. Were there any other questions? Does obsidian have any commercial value today? Yes, it does. There's always a market for flint knappers. So some of the more colorful stuff can go as much as, I think, $25 an inch in terms of cut slabs if it's really, really primo stuff. Some people use it as healing stones. A lot of people use it for, knickknacks, decorative stuff as well. Landscaping. So it does have some. There's, like I said, a lot of the major stuff now that's for sale is coming from out of the country. If you look on YouTube, you can see a lot of the videos of Mexican obsidian sources that are just basically giant pits that are being mined for all this various stuff. Is opaque obsidian harder to work than the vitreous? No. Really, it comes down to the phenocrysts. Those are what really kill it for me. because when you're making a point, you hit an ash pocket, the flake just dies right there, and then you're stuck with step fractures. So usually when you see something that's hackly, that's not toolstone quality material. But I've worked pretty much everything else in between in terms of surface color, surface sheens, and really just comes down to the source. Like I feel like some of them are a little bit more brittle than others and might break. Others are a little bit better. The Napa, of course, everyone talks about being one of the nicest ones. I've had a chance to work that stuff. They do nickname it black butter, and it certainly lives up to that nickname. And like I said, the borax lake stuff, it's really frothy, but it's used a lot and it's traded around a lot. And that, in my mind, is, I just don't know why, because it's frothy and it doesn't look that good. All right, the oldest workpiece in California. I'm not quite sure on the date. I know Greg White gave a talk last month about the Borax Lake site. If you look into his stuff, you will see some really, really early hydration dates. And quite frankly, I feel like people just ignored them because they figured there was no way that there could be people here that early. But I really think we should just go back and reconsider that. I think, with some of the more recent developments of the white sands and even possibly that mammoth stuff, there's certainly that possibility that, there's some really old stuff out there, and it should be at the quarries at least because they're going there to get their tool stone. I mean, the really first artifacts they would have found was the secondary deposition in the riverbeds, and then they would just followed it upstream, finding bigger and bigger nodules until they stopped in the river, didn't find it anymore, and then they just head uphill until they hit the source. Same way you find gold.
Can I just ask a question?
Yeah.
Can you speak to I'm trying to remember the things that when I studied the Native American, the uses for obsidian besides projectile points, and then they had the large one that you showed.
Mm-hmm.
Can you speak to that a little bit about the other uses? I believe there was a power issue having something like that for leaders of communities.
Yeah, so the giant wealth blade, that's a symbol status. So it shows that, hey, I have this great big thing. I'm bigger than you. You don't have this, blah, blah, blah. So that's one of the other uses for obsidian. They're naturally not using that to cut things. They'd also have tiny little needles, the obsidian needles. They'd use those, tie them to like dance regalia. I think they were called clinkers.
Forgot about that.
So they make certain noises as you're dancing around. Those have been found with some burials as well. And then it doesn't have to be a biface or projectile point. It can just be a flake manufactured into an expedient tool. But cutting, scraping, sawing.
Right. Okay. Thanks a lot.
No problem. And was it traded for Monterey chert or the like? I'm sure it was. I'm sure someone would have said, hey, I'll gladly take some Monterey chert if you get me some obsidian. Not sure why they would trade it for Monterey chert, but I'm sure it happened at some point. All right. Any other questions? It's looking like no. Well, thank you everyone for taking time out of your busy days and the extreme heat for joining me. And thank you so much for this opportunity.
Thank you, Luke.
Thank you.
Thanks, Luke.
Yeah, thanks, Luke. Thank you for such a well-rounded, or should I say sharp and pointy overview of obsidian. And join us next month to see Elaine Sullivan on her presentation on Egypt. Thanks again, Luke,
Thanks
for
much, everybody.
Thanks,
you.
Luke.
joining us. That was great.
Have a great rest of your day.
Take
Bye.
care.
You too.